Hello friends, welcome to my channel. In this video, I will cover ISRO Scientist 2017 17th December paper. I will cover question number 41 onwards. I will solve in this video. Question is, if f of t equal to e to the power at, its Laplace transform for s is greater than a is given by how much? So here we have to use fast shifting theorem. From fast shifting theorem, our formula is, if Laplace of f of t equal to capital F of s, then Laplace of e to the power at f of t, it will become, if here a is plus, then here s minus a will come. If a is negative, e to the power minus at f of t, then f of s plus a you will get. So here f of t is 1. We know Laplace transform of 1 equal to n factorial divided by s to the power n plus 1. So you will get 1 by s. Then if you multiply Laplace of e to the power at 1, here a is plus, so you will get 1 by s minus a. This is your answer. C is your correct answer. Smallest thickness which can be measured by a slip gauge is 1.001 mm. A is your correct answer. Question number 43. The deflection of an elastic member at the point of application of a force in the direction of that force is given by the derivative of member's total strain energy taken with respect to applied force. This is known as, we know from Castigliano theorem, del u by del f, it's equal to delta. Del u is your strain energy, f is your force, delta is your deflection. So here the derivative of total strain energy u with respect to applied force F delta, the deflection is your delta. B is your correct answer. Question is, the thumb rule between feed and nose radius in rough turning, it's F equal to 0.5 R. B is your correct answer. Which of the following is false statement? So, a reverted gear train is one in which the first and last gears are in same axis. Reverted gear train, you will get gear 1 and gear 2. Then gear 2 and gear 3 both are collinear. Gear 3, here gear 4. 1 and 4 both are in same axis. And 2 and 3 both are in same shaft. So here a reverted gear train in which first and last gears are in same axis. So 1 and 4 both are in same axis. So this is correct. Then train value for a gear is the ratio of product of driven tooth members to the product of driving tooth members. Driving members are odd numbers, 1, 3, 5. Driven numbers are 2, 4, even numbers 2, 4, 6, like this. So here we know velocity ratio is here n1 divided by n2 or t2 divided by t1. Number of teeth on the driver divided by number of teeth on the T2 represents number of teeth in driven gear and T1 represents number of teeth on driver gear. So always driver represents odd numbers and driven represents even number. So we know train value is your opposite of velocity ratio. Velocity ratio and your speed ratio and your transmission ratio all are similar, T2 by T1. If you multiply also, here you will get even by odd only it will come. Then your train value and your gear ratio they are 1 by velocity ratio. Here you will get odd numbers divided by even numbers. So here in this question, train value for the gear is the ratio of product of driven tooth. Driven tooth means even numbers divided by product of driving numbers, odd numbers, even by odd. So this is your false statement. These terms also are important, velocity ratio and your speed ratio, transmission ratio also they may ask, train value, then gear ratio also they are asking. Then C, a planetary gear train is one in which the axis of some of the gears may have a motion. Yes, this is correct. Then a compound gear train is one which had two or more gears on each axis. This is also correct. Which of the following is true for ductile metals? Engineering stress strain curve cannot have negative slope. Most applicable failure theory is maximum principal stress theory. No. For ductile metal, we are using maximum shear stress theory, MSST or MDET. Maximum distortion energy theory also we are using. Then ultimate strain is the strain at ultimate stress. C is your correct answer. Specific metal cutting energy. Specific metal cutting energy. Metal cutting energy FCVC divided by your MRR. Specific energy divided by your MRR. So here MRR is your VCF into D, feed into depth. This is also you can write in terms of area or original area. AO also you can write FC divided by A. So then you have to draw the merchant circle. If you follow the merchant circle, only small portion I am doing, not complete portion. So here this is FC, then your R resultant, then thrust force, FC is your cutting force, then here Fs, phi you will get, this is beta minus gamma, here you will get beta, here F, then your normal reaction N. Then we know shear stress tau equal to shear force Fs divided by shear force area. From here we can write Fs equal to tau into As. Shear area also, shear area, original area divided by, original area is your feed into depth of cut, original area divided by sin phi. Then from this merchant circle you will get Fs and R relation you will get. Cos beta minus gamma you will get Fc divided by R cutting force divided by resultant force. From here you will get cutting force Fc equal to R cos beta minus gamma. Then one more relation you will get, shear force Fs and R. You will get cos phi plus beta minus gamma. Gamma is your rack angle. You will get Fs by R. So here R value, from here you will put, it's equal to Fs is Fs and R equal to Fc divided by cos beta minus gamma. Cos beta minus gamma, or Fc you can write Fc equal to Fs cos beta minus gamma divided by cos phi plus beta minus gamma. This is Fc value. Then Fc value you put here. Fc value, A value also you got here, A value available. Then specific metal cutting energy Fc by A you can write Fc by A. Fc is Fs cos beta minus gamma cos phi plus beta minus gamma into original area A. Then Fs by A, here Fs by A equal to tau by sin phi. Fs by A equal to shear stress divided by sin phi. You can write shear stress divided by sin phi into cos beta minus gamma cos phi plus beta minus gamma. This is your answer. So from option, tau is your shear stress, tau cos beta minus gamma divided by sin phi into cos phi plus beta minus gamma. A is your correct answer. If you remember the merchant circle diagram, this type of questions easily you can solve. Sometimes they are asking this one also, beta minus gamma. Fc value, Ft value they will give. You have to find out beta minus gamma value. Sometimes friction angle also they are asking, or coefficient of friction also they are asking. Coefficient of friction mu equal to F by N. Here you will get F, and here you will get. This is the end of this part. Thank you friends. Thank you for watching my video. Thank you.